Good afternoon. How is everybody? कैसे हो सभी लोग? Okay, just tell me through the poll that you are able to hear me and also you can see the screen. Just let me know. Okay. Am I audible? Is my screen visible? Please let me know through the poll. चलो ठीक है. Thank you so much. Now let's start. Okay. So in today's class, what we are going to discuss, I have taken some two or three questions from electrical instruments, and then we will do some questions from capacitor. Again, nothing to worry about. Session will be like very much kind of easy and all. We will just deal with the basic, and but while dealing with the basic, we will also learn how to solve the questions. ठीक है? So you will be calm and relaxed throughout, but again you will be learning things. तो चलो start करते हैं. Yeah, this is the first question. Take your time, do it. Some 1.5 minute I'm giving to you, so do it. This is a very simple. This is from very simple device, that is your meter bridge or Wheatstone bridge का जो concept आप लोग पढ़े होंगे. So this is from that thing, and this concept is actually very easy. So we can easily learn it. We don't need more explanation and more concepts. This is very easy to understand. Okay, I got one answer and that feels incorrect. You need to recheck. Please recheck. Okay, so I feel like I need to deal with this question. Should I? Okay, I got some three answers and all are incorrect. Oh my God, what? You people didn't learn this thing? Anyway, no worries. Chalo, we will learn it here. Okay? एक second, just give me some time. Just 1 minute, okay? Okay. There is one term in current electricity, that is Wheatstone bridge. So Wheatstone bridge, if you have seen, it must be looking something like this. I just want you to know Wheatstone bridge का concept. ठीक है? So देखो कुछ ऐसा होता है ना? There used to be 5 registers. And we are interested in one particular case where this is connected to the battery, okay, where there is no current flowing in the R5. So there is no current flowing in the R5. So through this arm, there will be no current flowing. It means whatever current is going from here, yahan pe, there is 2 ways for current to travel. So some will go in this direction, another will go in this direction. Now when I1 is reaching here, again there are 2 ways, R3 and R5, but in balanced Wheatstone bridge, there won't be current in R5. So all current will go here. And here also similarly, I2 will go in R4, not along R3. Okay? So in balanced Wheatstone bridge, there will be no current in this arm. And in that case, you can easily prove R1 by R2 will be equal to R3 by R4. Okay? This is the case of balanced Wheatstone bridge. Now, meter bridge क्या होता है? So in meter bridge, R1 will be there, R3 will be there, R5 is replaced by galvanometer, since galvanometer also have some resistance. So here galvanometer arm is replacing this R5, and then R2, in place of R2 and R4, there is a long wire. ठीक है, जैसे यहाँ पे एक वायर यूज हुआ है AB. So this wire has certain resistance, certain length. So it has a length of 40 centimeter. This wire has some resistance. So what is the function of meter bridge? Meter bridge is used to find out unknown resistance. Okay. Let's forget the function of meter bridge. How will it work? So यहाँ पे हमारा काम ये होता है कि we move this jockey, this is called jockey, on the wire AB until there will be no current through the galvanometer. So again, balanced Wheatstone bridge जैसा. So suppose कर लो at point J, there is no deflection in the galvanometer. Then let's say AJ has a resistance of R1 and BJ has a resistance of R2. And these resistances will be parallel to their length. ठीक है. So क्योंकि रेजिस्टेंस का फॉर्मूला क्या पढ़ते हो आप, रो एल बाई ए पढ़ते हो. ठीक है. So now let's come back to the question. So that sorry. So in the given circuit shows a uniform straight wire AB of 40 centimeter length fixed at both ends. In order to get zero reading in the galvanometer we are getting zero reading. यानी कि balanced Wheatstone bridge case we are getting. The free end of J is to be placed from B. So there is a plain formula for this actually. I explained this one so that I can make you understand. So what will be the formula? If this resistance is R3, suppose, and this is R4, then R3 by R1 will be equal to R4 by R2. Agree? है ना? So suppose this is at length L from the B. So this length will be how much? 40 minus L in centimeter, because whole length is 40 meter. Now let's put the value. R3 का value क्या है? R3 is your 8 ohm. R1 is your how much? R1 is row length by area. So row length is how much? 40 minus L by area of cross section of the wire is equal to 12 divided by again row, because this is the same wire, row will be same, L by 8. आप इसको cut कर दो and then you will get the answer. So 8 by 40 minus L is equal to 12 by L. ठीक है. So directly you can write R3 by 40 minus L is equal to R4 by L. Directly you can write this. है ना? I wrote this much just to explain you. ठीक है. Now let's see. What will be the answer? You all must have calculated it by now. So this will get cancelled like this. 2L is equal to 120 minus 3L. So 5L is equal to 120 L will be equal to 24 centimeter. So correct answer will be how much? 24 centimeter. Anyone having any doubt? So इस क्वेश्चन में हम लोग क्या सीख रहे हैं? Through this question we are learning what is Wheatstone bridge and what is balanced Wheatstone bridge and what is meter bridge. So in meter bridge, two registers are replaced by a wire. ठीक है? And this middle one register, that is R5, is replaced by galvanometer arm. But technically both are same. Conceptually both are same. ठीक है? Anyone any doubt? Anyone having any doubt? चलो ठीक है. So now let's do this question. This is a question of a meter. A meter you must have studied. You can send me answers in the chat box also, and also you can vote in the poll, whatever you feel comfortable in. Okay, I got one answer, and that is not correct actually. You need to recheck. Recheck it, please. Okay, one correct answer I got. Three correct answers. Very good. Others, please. Everyone, come on. Yes, more answers, please. Okay. I'm ending the poll now. Okay, so what is the question? Ammeter. Ammeter का काम क्या है? Ammeter function is to measure current. ठीक है? And to measure current, how we connect ammeter in the circuit? In series. ठीक है? So पहला, what is ammeter? Basic definition, and then how we connect. So how we connect it? We connect it in series. सीरीज में कनेक्शन होता है. ठीक है. Now look at the question. A galvanometer has a coil of resistance 200 ohm. So there is a galvanometer. It has a resistance of 200 ohm. ठीक है. With a full scale deflection of 20 microampere. कहने का मतलब क्या हुआ? Galvanometer, if you have seen in your laboratory, it has some marking. कुछ ऐसे marking होते हैं ना. And there is one needle which will be at the zero mark. When current will flow to the galvanometer, this needle will move, है ना? Or depending on how much current is flowing through the galvanometer, that much deflection it will show. And for certain value of current, this needle will deflect fully. Yani ki it will start moving from zero, and it will go on till the final mark. So this is full scale deflection. ठीक है. So full scale deflection के लिए certain value of current it takes. Here that value given is 20 microampere. Correct है? The value of resistance to be added to use it as an ammeter of range this. अब देखो अमीटर हम गैल्वेनोमीटर से बनाते हैं. हाउ? To convert galvanometer into ammeter, we connect a small resistance in parallel with the galvanometer. ठीक है. So यहाँ पे भी if you want to indicate ammeter, you connect a small resistor called shunt इन पैरेलल विद द गैल्वेनोमीटर. ठीक है. सो यहाँ पे हमने कनेक्ट कर दिया. अब ये क्या बन गया? अब ये पूरा डिवाइस हो गया अमीटर. ठीक है. और हमारे क्वेश्चन में अमीटर का रेंज कितना है? 0 से 20 मिली एम्पियर. मीन्स मैक्सिमम करेंट दैट दिस अमीटर कैन मेजर इज 20 मिली एम्पियर. ठीक है. सो मैक्सिमम करंट गेटिंग मेजर्ड इज 20 मिली एम्पियर. इसका मतलब जो यहाँ पे करंट आ रहा है टोटल इन द अमीटर दैट इज मैक्सिमम 20 मिली एम्पियर. अब देखो द करंट दैट इज कमिंग एट ए विल गेट डिवाइडेड इनटू टू सेक्शन, one along the galvanometer and another along the shunt. अब देखो galvanometer के क्रॉस कितना करंट जाएगा? मैक्सिमम दैट इट कैन टेक. हाउ मच मैक्सिमम करंट इट कैन टेक? 20 microampere given in the question. So out of 20 milliampere, 20 microampere will go in galvanometer arm, and rest, that is 20 milliampere minus 20 microampere, will go through the shunt. क्लियर है? अब देखो अब क्या करना है तुम्हें. अमीटर का इक्वेशन अब हमारे पास सिंपल है. तो हमारे पास एक शंट है एंड देन देयर इज अ गैल्वेनोमीटर. वी हैव डिवाइडेड करंट इन बोथ द आर्म्स. हियर करंट एंड हियर करंट, they are in parallel, right? Galvanometer and this shunt are in parallel, so voltage across these two will be same because they are in parallel. ठीक है. So equate their voltage, that is the equation of ammeter. ठीक है. So इसके क्रॉस वोल्टेज एस के क्रॉस कितना होगा? S into S is the resistance, right? So S into current. Current कितना गया था? 20 मिली एम्पियर minus 20 microampere. ठीक है. And this will be equal to how much? Current through the galvanometer 20 into 10 to the power minus 6 into resistance of galvanometer, that is 200. अब देखो इन द क्वेश्चन ऑफ अमीटर हमारे लिए क्या इंपॉर्टेंट है? हमारे लिए ये इंपॉर्टेंट है कि हम ओके. सो हमारे लिए इंपॉर्टेंट ये है कि हम अप्रोक्सीमेशन कैसे करें. ठीक है. सो हियर यू कैन से दिस इज इन 10 to the power minus 3, this is in 10 to the power minus 6. So this value is 10 to the power 3 times greater than this value, right? So we can neglect this to solve the question. So आप neglect कर दो. आप क्या लिखोगे? अब यहाँ पे लिख सकते हो फाइनल आंसर के लिए. आई एम टेलिंग यू S into 20 into 10 to the power minus 3 is equal to 20 into 200 into 10 to the power minus 6. So that is your 4 into 10 to the power minus 6. ठीक है. So sorry, minus 3. ये कैंसिल हो जाएगा एंड व्हाट यू आर गोइंग टू गेट? S will be 4 by 20. So that is equal to 0.2 ohm. ठीक है. So correct answer will be C. So I hope I explained to you what is this ammeter, how we convert galvanometer into ammeter, what is the maximum, what is the meaning of maximum deflection current, and what is the meaning of range of ammeter, and then finally how we can write the equation for ammeter. ठीक है. So I hope that is clear. If not, you can text me, you can let me know in the chat section. ठीक है. चलो. Should I wait for your doubts? Anyone having any doubt? I just want you, because this class happens once in a week, right? So I just want you कि मैं जो भी concept को deal करूँ, little, that should be clear in your head. So that something you are carrying away from this class, and that something will become very much if you are attending it properly, and finally when you will be sitting in your examination. So ultimately that will matter. Chalo. Now do this question. Okay. I got six answers, and out of that, I feel like two of you are correct. Others, please consider your option. Okay. I got some more answers. Everyone, please reply. Okay. Four, five, 10 answers. Very good. Others, please, everyone come on and vote. Not some random options, rather the one that you're getting. Okay. Do participate. Because this is your class. This is your space. This should be owned by you only, right? So take this space. Okay, 12 of you answered. Let me share the screen. Okay, so let me now do that for you. What is the question? Question is very simple actually. Question is from voltmeter. So what is the question? When moving coil galvanometer is converted into voltmeter, how we convert galvanometer into voltmeter? For that we connect a high resistance in series with the galvanometer. So function of voltmeter is to measure voltage, and we connect it in parallel to measure the voltage, right? Now the series resistance is n times the resistance of galvanometer. Let's say its resistance is R, then its resistance is NR. How many times that MCG, the voltmeter, is now capable of measuring voltage? So initially, when only galvanometer was getting used to measure the voltage, suppose I current was flowing, then how much voltage it will measure? IR. Done. And now when NR is also connected and still I current is going through it, then voltage getting measured will be how much? IR plus INR. ठीक है? So how much value you are getting? IR को common ले लो, 1 plus N. So now it is measuring 1 plus N times more, right? So correct option will be what? Correct option will be your C. Done. Now let's do some question from capacitor. Do it now. You know energy is stored on the capacitor का formula. Energy is stored on the capacitor. If capacitance is C and voltage is V, then energy stored on the capacitor is how much? Half Cv squared. Done. Chalo, use it and let me know. JNV Yanam. Yes, no. No, actually, you need to recheck. I will relaunch the poll for you again. Just recheck it because there are two capacitors, not only one. West Godavari. Yes, very good. That is correct. Yanam, again, that is not correct. You need to check. क्वेश्चन क्या है, वर्क डन इन चार्जिंग फुल्ली बोथ द कंडेंसर. ठीक है, सो हाउ मच वर्क इज गेटिंग डन. सो वॉट एवर वर्क इज गेटिंग डन इज here nothing else is mentioned. So here whatever work is getting mentioned is getting stored on the capacitor. ठीक है, so if you look here carefully, voltage across this capacitor will be V because directly connected with the battery. क्योंकि इस end पे end A की बात करो and end B, then end A and B have a potential difference of V equal to the potential of battery. And in terms of potential, this point and this point share the same potential because there is no resistor or any electrical instrument connected in between. Conducting wire is there. So in terms of potential, this is also point A. And in terms of potential, this is also point B. Similarly, this is also point A and this is also point B in terms of potential. Because potential between 2 points will not change if those 2 points are connected by conducting wire. They will only change if some electrical things are there, like resistors or okay, one more correct answer. Great. Are there. ठीक है, so V हुआ. अब देखो इस पे एनर्जी स्टोर्ड कितना होगा, हाफ CV स्क्वायर, क्योंकि वोल्टेज इज V and on this energy stored will be half C by 2 V square. So if you're going to add these two, how much you will get? You will get 3 by 4 CV square. You can look at it in some different way also, like itna likhne ki zarurat nahi hai. You can see here C and C by 2 are in series or parallel. C and C by 2 are in parallel because potential difference between these two are same. And when capacitors are in parallel, how we calculate their C equivalent? So C equivalent we calculate by adding them in a series. जैसे the way we add resistors in series, the same way we add capacitors in parallel. So here C equivalent will be C plus C by 2. Just opposite तरह से add करते हैं. So this is 3C by 2. So energy stored on the capacitor is how much? Half C equivalent V square. So that will become 3 by 4 CV square. Chalo. Now do this question. Let me know. Very simple question. Only you need to do series and parallel thing. So let me know what you're getting, everyone. Great. 16 of you answered in the previous question. Okay. Tinsukia. JNV Tinsukia. Uh, yeah, that's correct. Okay, 3 of you answered in the poll. Why only this much little number of people has answered? What happened? Only one correct answer I can see in the poll. Sultana, yes. Kolhapur, yes. Okay, so what is the question here? Which of the following combination of 7 identical capacitors, each of 2 microfarad capacitance, gives a capacitance of this? So here 5 in parallel. If 5 are in parallel and if they are equal capacitors, then you will write like what? 1 by C equivalent equal to 1 by C plus 1 by C plus dot dot up to 7, right? So C equivalent, but in parallel they will get added like series. You cannot use like this because if capacitors are in parallel, you will add them like in series. So C equivalent, in first case I am doing फर्स्ट 5 को सीरीज में करना है तो फर्स्ट 5 को करो. सो दैट विल बिकम, सॉरी पैरेलल में है, सॉरी 5C and another two are in series. So सेकेंड सेट के लिए क्या हो जाएगा, सेकेंड सेट के लिए you will add them in parallel. So this will 2 into 2 by 4, and this will give you how much, 1 microfarad, and this is microfarad. ठीक है, and 5 in parallel and 2 in series. Okay, so now you can like 5 are in parallel. Just see how what it is given. Sorry, I got distracted. So they are in parallel, right? ऐसे है, and then 2 are in series. This things is like this, ठीक है? So इसका capacitance we are getting as 5 microfarad, and this we are getting as 1 microfarad. Again, these two are in series. So you will add them like in parallel. So how much we are going to get? Have I done some mistake? What happened? Okay, 5 in parallel, and they are each of 2 microfarad, ठीक है? So यहाँ पे this will be 10 microfarad. Sorry, really sorry. And this is 1. Now add them like you will add them in parallel. So 10 into 1 by 11. So this is equal to 10 by 11 microfarad. So in first only we are getting the answer. जैसे you don't need to get confused. If capacitors are in parallel, we add them in like in series. जैसे in series we add resistors like what, R1 plus R2 plus R3 plus R4. So in this way we will add capacitor only when they are in parallel. And when capacitors are in parallel, we will add them like in series. So parallel में कैसे add करते थे resistors को? 1 by R1 plus 1 by R2 करते हो ना, मैंने शॉर्ट में लिखा. So इसको क्या लिखोगे? R2 plus R1 divided by R1 R2. So R equivalent is what? Multiplication of both and then addition of both. So that I did. Multiplication of both divided by addition of both. Done it? So I hope it is clear. Now do this question. Question is very simple. Just simple logics are there. Everyone, please let me know your answers. Okay? And many of you do this, please. Rather, each one of you do this. 3 of you answered. 1 is correct. Come on, everyone. It means you people are not reading. क्या कर रहे हो तुम लोग? Basic formula should be there in your mind. Anyway, even if you are if you have not studied it till now, no worries. But in the class, you stay attentive. Okay, that I will expect out of you all. कैपेसिटर पढ़े हो ना तुम लोग? कैपेसिटर का कैपेसिटेंस का क्या फॉर्मूला लिखते हो? Only one correct answer I got so far. Anyway, I will. So I feel like I need to discuss. So if there is a capacitor, ठीक है, and Sultana, your answer is not correct, unfortunately. Let's see now. So यहाँ पे अगर कैपेसिटर है, कैपेसिटर कैसा होता है? एक प्लेट ऐसा होता है. इस फोन को देखो, एक प्लेट ऐसा होगा, and then there will be another plate like this. ठीक है? So one plate is this, another is this. Area is A. Separation between these two is D. ठीक है? Yes, that is correct. So if you have to write its capacitance, capacitance is written as what? If a medium between the plates is vacuum, in that case, permittivity is epsilon naught A by D. This is the capacitance, right? Now what is happening? Space is filled with dielectric. Yani ki, now this media is not left to be vacuum. It is getting filled with some other insulator. Okay? And its dielectric constant is how much? 8. It means now the capacitance will become what? You know that when we drop dielectric in between the plates of capacitor, and if dielectric has occupied the whole volume, in that case, capacitance will get increased by how many times? By that dielectric constant times. Okay? The capacity of capacitor is increased 16 times. और यहाँ पे हमने प्लेट्स के डिस्टेंस बीच के डिस्टेंस को भी चेंज किया है. क्वेश्चन को ध्यान से पढ़ो. In parallel plate capacitor with air between plates, the distance d between the plates is changed. Distance d is what? Changed, and then a dielectric is placed. And after doing all this, what is happening? Capacitance is increasing by 16 times. So suppose Karlo, finally, what we have done, we have increased distance in such a way that final separation is d dash. There is dielectric kept of dielectric constant 8. So capacitance will be k epsilon naught A by d dash. Okay? So what will be the value? 8 into epsilon naught A by d dash. So इसको ऐसे लिखो. Done. So this is c dash, and this is how much many times of c? This is 16 times c. तो c dash को हम लिख सकते हैं 16c, और 16c को लिख सकते हैं 16 into epsilon naught A by d. So this will get cancelled. This will become 2. So d dash will become how much? D by 2. So this is the answer. This is what you need to remember. Capacitance will increase by dielectric constant times when we insert dielectric inside. And first thing that we needed for this question is formula of capacitance, epsilon A by D. If it is vacuum, then epsilon naught. If it is not vacuum, some other dielectric, then it is K epsilon naught A by D. Now do this question and let me know your answer. Okay, 6 of you answered. 1 correct I got. 2 correct I got. Very good. Come on, everyone, answer, please. K is T. Chenbi Tinsuki. Sultana, yes. How to solve questions? Like if you're getting confused in A और B के बीच में कौन series कौन parallel है, series में तो ये 3 दिख रहा है clearly, है ना? So there is no problem in that. Yes, good moon. So rest is कि ये 3 और इसके बीच में क्या relation? So you just mark the points according to their potential. This point has potential of A. अब देखो A से इधर जाओ तुम, इधर only wire is there up to this, then capacitor is coming. So this is also A in terms of potential. Similarly, this point is B in potential. Take 2 separate points, A and B. Now along A and B, these three capacitors are there in series. So add them in series like this, these three. And then between A and B, there is one more capacitor like this. Okay? So along A and B, now calculate C equivalent. So these three are in series. We will add them in parallel, according to the formula. So this will become C by 3. Done. And C by 3 and C are in what? Parallel. So you will add them like in series. So C by 3 plus C, that is 4C by 3. So answer will be what? D. Okay? Chalo. Now do this question again. Use the same logic, draw the diagram clearly, you will get the answer. Okay. 5 of you answered, 6 of you, and 2 is correct. 2 are correct, sorry. Okay, more of you answer, please. Okay. Okay. Janvi Tinsukia. Oh, you are getting it wrong actually. You need to recheck. Maybe you are doing some mistake in the calculation. No, again, that is incorrect. So only 2 of you got it correct out of 14 polled or voted in the poll. Let me do this for you, no worries. This is, though 2 points are marked, right? Chain B, Kolhapur. Again, it's wrong. Let's check now. A is this, B is this. We have to calculate CAB, C equivalent across A and B. Now, if I say like this is A and this is B, in terms of potential, you mark the points. That is the logic. Suppose इस point के potential को, इस point को मैं C बुलाती हूँ. So this point is also C in terms of potential. This point is also C in terms of potential, right? Similarly, what I'm doing, I'm calling it D in terms of potential. So this is also D and this is also D. So how many points are there? Okay. Kolhapur, previous question. ठीक है, पहले ये explain करती हूँ, then I will go with the previous one. ठीक है? चलो, क्योंकि मैं यहाँ middle of discussion में हूँ ना. So in terms of potential, how many different points we got? A, B, C, D. So एक काम करो, A ले लो, B ले लो, C ले लो, D ले लो, ऐसे. ठीक है? अब आप एक काम करो, ए और सी के बीच में कैपेसिटर है, ट्राई टू लुक एट ए, बिटवीन ए एंड सी देयर इज वन कैपेसिटर, एड इट हियर. नाउ बिटवीन ए एंड डी, yes, between A and D also there is one capacitor, add it here. Now between C and B, is there any capacitor? Yes, this one. So add one here. Between B and D there is one capacitor. Yes, there is one. And between C and D, yes, there is one. All has equal capacitance, 1, 1. Again, use the concept of balanced Wheatstone bridge. Here, this bridge is balanced because C1 by C2 is equal to C3 by C4. 1 by 1 equal to 1 by 1. Equal, right? So, along this, there will be no potential difference. C and D will share the same potential because no current will flow along this, right? Now, if there is no current flowing through this, it means whatever current is coming here will go here. So these two are in series, these two are in series. Correct? So इन दोनों को series में है तो parallel की तरह जोड़ो. 1 and 1 in parallel will become 1 by 2. Similarly, 1 and 1 in parallel They are in series, but we will add them like in parallel, will become 1 by 2. And this 1 by 2 and this 1 by 2 are in parallel, क्योंकि ये और ये आपस में किसमें है? Parallel में है. So 1 by 2 and 1 by 2 in parallel, you will add them like in series, so that will become 1. किसी को डाउट है इस क्वेश्चन में? Anyone having doubt in this? किसी के पास डाउट है? नो? ओके, वेरी गुड. ठीक है. So answer will be what? 1. Someone said कि previous question में क्या doubt है? You can unmute yourself if you want to speak. लाइक प्रीवियस क्वेश्चन को अगर मैं तुम्हारे लिए रिपीट करूं तो यहाँ पे देखो, सबसे सिंपल सा चीज ये दिख रहा है कि ये तीनों सीरीज में. सो एड देम लाइक इन पैरेलल. सी इक्विवेलेंट ऑफ दिस 3 विल बिकम सी बाई 3. ठीक है. उसके बाद ये c by 3 एंड दिस c आर इन व्हाट? पैरेलल और सीरीज. दैट वी नीड टू चेक. सो इन टर्म्स ऑफ पोटेंशियल अगर देखो तो इस इनके बीच का पोटेंशियल डिफरेंस क्या है? दैट इज सेम एज पोटेंशियल ऑफ ए एंड बी. ओके, कोल्हापुर. अंडरस्टूड ना? So it has a potential of VA minus VB. It has also potential of VA minus VB. They are in parallel. So C by 3 plus C, right? चलो ठीक है, आगे चलते. Do this question. This question is also in your NCERT. एनसीईआरटी का कैपेसिटर का, यानी कि इलेक्ट्रोस्टैटिक पोटेंशियल का जो चैप्टर है, गो टू दैट चैप्टर, यू विल गेट दिस क्वेश्चन. जेनवी रायचू. दिस इज नॉट करेक्ट. You need to recheck. 7 of you answered, 2 of you are correct. देखो, this is a concept actually. You need to read this. Suppose parallel question क्या है? Parallel plate capacitor is charged by connecting 2-volt battery. So there is a capacitor. We are charging it with a 2-volt battery. ठीक है? So if it has capacitance C, how much voltage will drop across this capacitor? All the voltage of battery, because there is no other electrical instruments upon which voltage can drop. So here 2 volt will drop. All voltage of battery will drop across the capacitor. So how much charge this capacitor will have? 2CV. 2 वोल्ट को मैंने 2CV, क्योंकि Q इक्वल टू क्या होता है? जेनबी 300 किया. यस, Q इक्वल टू क्या होता है? CV. सो C इंटू 2 वोल्ट मैंने किया, इतना रहा इस पे चार्ज. नाउ व्हाट वी आर डूइंग, इट इज देन डिस्कनेक्टेड. नाउ वी आर डिस्कनेक्टिंग इट. So when it was connected, it has positive charge, it has negative, because it is connected with positive terminal of the battery. So when battery will get disconnected, it will have positive charge like this. It will have negative charge like this. है ना? And a glass slab is introduced between the plate. यानी कि we are inserting dielectric. Which of the following pair of quantities decrease? Now, when you have disconnected a capacitor from the battery, and this capacitor has some charge, 2CV. Now what you are doing, you are inserting a dielectric in this space. What will happen because of insertion of this dielectric? See, charge will go nowhere because like for charge to flow, it's this capacitor should get connected to another capacitor to another system, then only charge will flow. Now this is isolated, this is not connected to anything, so whatever charge is on the capacitor, that will remain there, right? So q will remain unchanged. q क्या हो जाएगा? Unchanged रहेगा. Again, because of adding dielectric, capacitance increase करता है, मैंने अभी अभी बताया, it will increase by k times. So here capacitance will become how much? Initially c naught, then final c will become kc naught. ठीक है? Now what will happen to the potential difference of these two, and what will happen to hence electric field between plates? So when you will keep dielectric here, because of dielectric, electric field between the plates will get affected. Okay, it will decrease. Electric field here because of dielectric will what? Decrease. So potential will decrease. Done. So V will be less than V naught, and electric field will be less than E naught. Okay. Now comes the question of what? Now comes the question of energy stored. So energy stored ka one formula is half CV square. That you can also write as Q square by 2C. So Q is remaining unchanged. Q square by 2C. C is becoming K times. So energy stored will decrease. Okay. So what are decreasing? Now check. Potential will decrease. Energy stored will decrease. Yes. एनर्जी स्टोर्ड इन कैपेसिटेंस, कैपेसिटेंस तो इंक्रीज कर रहा है. कैपेसिटेंस इन चार्ज, चार्ज तो अनचेंज्ड है. चार्ज इन पोटेंशियल डिफरेंस, चार्ज तो अनचेंज्ड है. पोटेंशियल डिफरेंस इज डिक्रीजिंग, राइट? So correct answer will be A. Please look into your NCERT textbook. There is question related to this. Okay. Clear है? Anyone having any doubt? तुम लोगों के लिए स्पेस ओपन है, ठीक है? बिकॉज विद क्वेश्चन वी आर डन. आई हैव एक्सप्लेन्ड इट. इसमें किसी को डाउट है इन दिस क्वेश्चन? Anyone having any doubt? No, ma'am? Okay. So I will repeat this thing like in a more okay. So let's do this. So I told you just now two things. Suppose कर लो हमारे पास. I will just explain the question of that NCERT. So there is a capacitor, okay? It is connected to a battery, first case, and then there is a capacitor. It is it was initially connected with a battery, but now it is disconnected, just like in our question. हमारे question में जो था. So in our question, there was a capacitor charged. Let me draw it more clearly. So something like, so these two cases are there. It also is what we are doing. In both cases, we are dropping the dielectric. We are adding the dielectric here. Here also we are adding a dielectric throughout the space. Okay. So this case I discussed. Let me discuss this one. Okay. So you are adding the dielectric. When you will add the dielectric, I told you capacitance will become K times. है ना? That will become K epsilon naught A by D, as I told you before in the question also. So C is going to increase. Now what will happen to charge? This charge. You just see here, capacitor's capacity is increasing. It means it can store now more charge. So it has capacity to eat more. And there is a battery which can give it food, which can give it charge. It means the moment its capacity will increase, this battery will supply it with charge. So definitely Q here will become K times initial charge. Here Q was remaining unchanged. Q, क्योंकि capacity was increasing. But since it is not connected to any battery, there is no any food provider, charge provider. So here charge will remain constant. ठीक है? So यहाँ पे unchanged है. Done है? अब यहाँ पे आप देखो, since this is connected to a battery of voltage V, done. And here because of adding dielectric, what was happening? Since when you will add the dielectric, what will happen? On the surface of dielectric, here negative charge will get introduced, here positive charge will get introduced. So because of induced charge, electric field is in this direction, and because of charge on the capacitor, electric field was in this direction. So overall electric field decrease kar gaya, hai na? But here you can see this is connected to the battery. All the voltage will drop on the capacitor. So every time voltage drop across the capacitor will remain V. Okay? Hello. So it will remain your what? Hi. I can see all girls who are sitting there. And it is such a good feeling. Hello. इसी तरह तुम लोग पढ़ाई करो, है ना? It is very important that you people read, especially for girls. Boys, they should also read. But yeah, girls should read more. You need it more. है ना? Because you're not given power so much. You need to snatch that power. So snatch that power. Read it. ठीक है? So here this is this. Now Q is unchanged here. Q is changing here. If you talk about voltage, so this capacitor is always connected to the battery which has a voltage V. So this battery will maintain voltage V across the capacitor. Okay, so here V will remain unchanged and hence electric field will remain unchanged क्योंकि electric field और voltage के बीच का relation क्या है? E by D equal to V, where D is distance between the capacitor. So these are all things that you need to remember. Capacitor में this portion is very important. From this you will be getting question in your board also and also in your competitive exams. So simple things what you need to remember in capacitor is how to add capacitors in series and parallel, first thing. Second thing, what are the formula? Charge on capacitor, Q equal to CV. Energy stored on the capacitor, half CV square. Voltage across the capacitor is V, then what will be potential difference? Voltage across the capacitor is V, then what will be electric field? That will be your V into, सॉरी मैंने फॉर्मूला गलत लिखा है, दिस इज गलत, ठीक है, V इक्वल टू ED होगा, ठीक है, डन है. सो अगर मैं तुम लोगों को क्विकली एक फॉर्मूला यहाँ पे सारा लिख दूं तो फॉर्मूला कुछ ऐसा होगा. अगर ये कैपेसिटर है, इसका कैपेसिटी का फॉर्मूला, अगर ये वैक्यूम है तो C होगा एप्सिलॉन नॉट A by D. अगर तुमने इसको बैटरी से कनेक्ट किया है जिसका वोल्टेज V है, चार्ज ऑन कैपेसिटर विल बी CV and what will be energy on the capacitor, half CV square. इसको Q square by 2C के फॉर्म में भी लिख सकते हो. And after that what else you can do here, like what will be the potential difference here? It will be V. What will be the electric field? Electric field will be your V is ED, so electric field is V by D. ठीक है. One more thing, if there is a capacitor given and there is a charge here, and if one will have negative charge, and if it is asked that here the charge density is plus sigma, which is sigma is Q by A is the area of cross section, and then you are asked what is the electric field between the plates. So electric field formula will be sigma by epsilon naught. ठीक है. So these are the formulas you need to remember. उसके बाद तुम्हें याद ये रखना है कि डायलेक्ट्रिक को ऐड करोगे with or without battery, then what will be the effect on all these different things. So that is all you need to remember in capacitor. I hope capacitor revision kind of things happened for you people. Anyone having any doubt? I will take the doubt, otherwise we are good to go now. Hannah, your playground is also waiting for you. You people can play, Hannah. Oh no, there must be class. After 5 you will play, Hannah. Chalo, ठीक है then. Bye. Take care, everyone. Thank you so much for joining the class, for responding in the class, for staying in the class, and then for being so much attentive. Thank you so much. Everyone, take care of yourself and bye bye. Bye. Chalo, bye bye. Thank you. Thank you. Bye. I will come and meet you people very soon. I hope. I hope it's possible. चलो ठीक है बाय. तुम लोग इतना प्यार दोगे तो मैं जा नहीं पाऊंगी. ठीक है. वो बाय. अब मेरे को सच में जाना होगा. बाय. टेक केयर.